Welcome to a new test and teardown video. This time it's a Nucletronics from Denmark ICI 510. I got a few of these units, different kind of types, but I think they do more or less the same thing. I think they're measuring some sort of radioactive levels using external probes. See, I also got one of the probes. This is a mulot probe. And I think you use the radioactive measurements for welding approval or quality of weldings. So I think that when you have welded some sort of a gas pipe or something important, you can put a radioactive source inside the tube, and then you can take your probe and probe around your welding and see if your welding is perfectly tight and same thickness all the way around, and this way approve the quality of your welding. Please correct me if I'm totally wrong, because I am so far out of my normal league when it comes to welding and stuff like that. It's definitely not my thing. Yeah, all of these units, they were really thrown in a container or something like that. So we have handles and loose parts in here. When I move this, I hear parts flying around. So I think we should open this first and then have a look. I've only been inspecting the front a little bit, and I can see that what I think happens here is that will be the input, and then you use the keyboard to input like ID codes and some factors of this and that and dates and whatnot, and then it's gonna go on your printer, and then you can do continuously or single sweep, and then it's gonna probably write the the radioactivity level or thickness level or quality level or something like that. And yeah, let's just open it and have a look, right? I think I already found a good explanation for the loose items, because look at that, will be the circuit boards. They fell out of the socket and there isn't any lock for that. So when you drop the unit, I mean, we can see evidence that it was definitely thrown to the ground. And that is, of course, how you release those boards. I think to get them out, to inspect a little bit deeper, I need to probably take off the rear side or something like that. What else can I see? Some cable here for the printer interface and a really cute microcontroller or something like that, right? Oh, so they made their own printer interface. That is a little bit impressive. That'll be the paper. What type of paper is this? We've got all sorts, some circuit boards with all sorts of stuff up there. It's looking a little bit like a product you don't make that many of, right? That case and all this is a little bit internal prototyping, proof of concept, sort of building style, wouldn't you say? I like the really big limo connector here. Nice. And that will fit the connector we got for the sensor, and they handle high voltage and high current and all that kind of stuff, because I would expect the sensor here to be some sort of a Geiger type of detector. We can probably get in there somehow. Maybe we can get in there. I don't know yet. Look at the way the cables are soldered to the limo. And everything else here is, I mean, a little bit down to prototype kind of level. So maybe this is an internal prototype. I want to have it down here so I can probably pull out some of the circuit boards I should maybe only pull out one at a time. What have we got here? Says no. No real info. But I should probably just look up those ICs, right? They're 9901, and both of them the same. But look at the date code, 79, 84. Whoa. What is that? 80. Okay, this explains the build quality. It's really, really old. So, I mean, this one was probably the original IC79. Well, that one has been replaced, right? Because everything else is 80. Okay, that is very interesting information. And this is the next one. What have you got here? Look at that big. I think it's a processor. So it's a Texas Instrument TMS9900. What the heck did I miss? I will have to look this up. And then, of course, 2 EEPROMs, because that will be 16 bits. Don't you think so? This size of processor. This looks a little bit like a 68,000. It's probably the same sort of. And it says Mini Lab. Wow, cool. And again, Mini Lab. So that's probably the CPU cards and all that kind of stuff. Is well, something they bought from something else, right? Mini Lab CPU, and it says probably some 82. What is it with this dumb bird? So I did a little search. It turns out the TMS 9900 CPU is one of the first CPUs like this, all in one CPU. It's a 16-bit, and it's running on positive 5 volts, negative 5 volts, and plus 12 volts. Really weird. And you need 4 phases clock as well. So, and even that, it takes 127 cycles to do some division in 16-bit integer. I mean, even an Arduino is faster. I mean, so yeah, this is of course why we have 2 EEPROMs, because it's 16-bit. All the other ICs I talked about, the TMS 9901, that will be a programmable input-output, and they use an 8-bit data bus and some other funny signals to communicate with the CPU. So that is just input-output boards, and they look a lot like the same. I don't want to swap them around because it's probably going to cause all sorts of problems. Yeah, and no, they're not exactly the same. Not exactly the same layout, but more or less there are definitely ideas of the same design. I also found some web pages. People still play around with this TMS 9900 series CPUs. You can still buy boards and processors and hardware, and people, they still play with software and all that kind of stuff. I think that is really funny. Here is one of the circuit boards they made themselves, and it's of course with the right Nucletronics. Oh, they're even from the same city as where I live. Same postcode. What the heck? This is, I mean, a few kilometers away. How cool. And I haven't heard about them. So that will be all sorts of digital interface. Oh, op amps and analog stuff as well. Some, oh, you know what that is? This is, of course, the high voltage generator. Look at that. 220 mega ohm high voltage capacitors. So this is a little switch mode converter to generate the high voltage for the sort of a Geiger sort of tube is what I expect we'll be able to find. So this is what they are doing. Okay, so those wires go to a little trimmer and indicator. It also says high voltage stuff right there. And yeah, I definitely want to look at the printer interface as well. I just realized if you look at the paper reel for the printer, the way that you get the new reel of paper in, you see, you need to get up here via this groove or this slot. So to do that, the printer must go either in or out. Ah, here is a connector, right? So this is probably the back plane for the printer, and this is probably a connector. No, I had the idea the printer was going out in the front. How is this? See, maybe you just unscrew some. See, they got finger screws here at the front, so maybe this is the idea. How are you going to access the paper? So I think I figured this out. So the whole idea is the front, we have these two little finger screws, and then it's hinged. So all you have to do is just bend down the front and then pull out the whole printer unit. I think in real life you only have to pull it out to this position so you can access the paper reel, right? So, but I pulled it all the way out just so it's more fun to have a look at this printer. I think it is really, really fun to see, I mean, how little is really required to do a little printer. So those tiny little units here is actually a needle printer unit, and it's using ink tape. All you have to do here is just push this all out, and then you'll see the ink tape. Ooh, it's actually cracked like that. So I'm just gonna wind it a little bit, and then hopefully we can get a little bit out of this. But then there's a little printer head here that moves back and forward, and then it prints on this tiny piece of paper here. That's all there is to say about it. All these wires here from the printer unit. And that is it. Tiny little circuit board here. It really don't require a lot to do that. Amazing. Oh yeah, also I found another little funny thing. The keyboard here in the front. See, this is the 74C922. That is a keyboard scanner chip, and it outputs the 4 bits and a keyboard pressed feature, and then you got power supply and I don't know what else. So that is all there is to it. So they don't scan the keyboard using their own software, but just read this, and then the switches here on the front, that is just entirely handled by software. They don't do anything directly. They input something to the software, right? Oh, and the 7 segments. Oh, let's get some light in here. Look at that. Nice. I don't understand what that is. Calibration or configuration or something like that. So let's try and do the first power up test. First, I just switch on mains and nothing bad happened. Oh, look at that. That's not bad. It's using 40 watts. So that is the ID code. Let me see if I can. Oh, look at that. So it is responding to this factor date. So that's also responding to all this. How cool. And then what is that? Click. Can you hear? So it's going into busy. It just went. It said clickety click and then it went off. Okay, so. Shit, man. I murdered it. Okay, so there's. Okay, yeah, that was it. Well, of course I didn't expect this to work or anything, but could have been cool to play with the printer, so I shouldn't have done that. But anyway, I didn't expect much. No, that was it. So, what else can I explain? Yeah, this sensor I will open in a minute. I think so, or maybe I will just keep it as it is for one of the other testers I got. But I can reveal to you some of the parts. I had another sensor that was completely broken, but I was able to pull it apart and find all these components inside of it. So at the very front of that sensor, it's a bigger sensor compared to that one, right? We had this aluminium surface like that. And then this is a Photo Multiplier tube. Absolutely beautiful piece of equipment. And all these segments, yeah, sort of multiplies the light that comes in. And there's a tiny little, I think this is a current it delivers on this plate. So there's maybe also a filament or something down here, right? So it's really a tube, a radio tube that is just insanely sensitive to light. It's absolutely beautiful, by the way. Yeah, so this is the sensor surface, the aluminium part here, right? And what you see here is a very special sort of phosphor behind this glass. And I also think this glass is kind of special. And they lubricated this with some sort of a nasty, sticky, gross stuff. And then it was kind of sticky to the sensor like that. And we had lead and steel seals and whatnot, so that all the radioactive particles could only come here, right? And not affect anything else. And then here's a nice little socket and thin wires that goes to this circuit board like that. So that will be all the biasing resistors for the acceleration plate. So each of these plates, they have a different voltage and then a little transistor circuit for amplifying this. And yeah, so only 4 wires goes out of the sensor, including shield, of course. And that is how they detect this radioactivity using phosphor and not a Geiger counter. Yeah. I'll save this definitely. Probably use it for something fantastic one day. Oh, don't you just think it's lovely? This is one of them with really, really a lot of sections, so I kind of like that one. Maybe there's a possibility to figure out what kind of sensor this one is. Maybe we can look this up somehow. Ooh, you can hear there's some stuff in here. It was probably explained here on this text. Type. Haha, there is some stuff here. Oh. Type. I'll see. I'll see if I figure this out anyway. Yeah. Not yet. Yeah, I'll go and play with some of the other units instead. This was no fun anyway. But I just wanted to show you what was inside this unit and how it was designed. I hope you enjoyed it at least a little bit. I'm sorry I kind of blew it up. It's completely... That's just what happens. It's gonna go back in the junker. So anyway, thank you very much for watching. Please like, subscribe, and tell your friends. Bye bye.